Nuclear reactors on the Moon, a stepping stone towards the colonization of Mars. In the future of space exploration, establishing long-lasting human colonies on the Moon, and then on Mars, is one of the major challenges. To ensure the autonomous development of these colonies, reliable and abundant energy access is essential. Nuclear energy could play a key role, especially through innovative reactors tested first on our natural satellite, the Moon. These new lunar nuclear reactors present a unique opportunity to develop and validate reusable technologies for future Martian colonies. Before you start the vid, please subscribe to support our channel and share it to your friends and relatives to be sure to see our next video. Thank you so much for your attention. Let's start. The constraints related to establishing space colonies are considerable. Resources must be transported at enormous costs from Earth. The extreme living conditions between polar temperatures and exposure to radiation require resilient infrastructures. Autonomy from our planet is imperative for the long-term survival of the colonies. In this context, nuclear energy has many advantages, including providing abundant and sustainable energy without depending on regular deliveries from Earth. Today, the technology of conventional thermal nuclear fission reactors does not fully meet the needs of space colonies, in part due to certain long-lived radioactive waste. New reactor concepts such as molten salt reactors are under development by space agencies such as NASA. These fourth-generation reactors have the ability to burn some nuclear waste and limit the production of minor actinides with long lives. The principle is to immerse the nuclear fuel not in water, but in a bath of molten salts at very high temperature in order to optimize the chain reaction. The Moon could be the ideal terrain to test these new nuclear reactor technologies to full scale before deploying them on Mars. Firstly, the Moon's very tenuous atmosphere avoids issues related to radioactive waste on Earth. Craters or ditches could even serve as permanent storage sites. Moreover, the lunar environment presents conditions similar to those early Martian colonies could encounter. Comparable gravity and temperatures, exposure to radiation, locally exploitable resources. On a practical level, the Moon's relative proximity would facilitate transporting the initial fuel and astronaut maintenance operations. The Chinese, European, and American space agencies are currently working on concepts for lunar nuclear reactors. China is notably considering a 10 MW molten salt reactor as part of its future Lunar Palace 1-inch base planned for the 2030s. In the United States, NASA is developing with the Department of Energy a 40 kilowatts fission surface power system project based on a more conventional pressurized water mini-reactor. The European Space Agency is studying the option of a small demonstration reactor of a few kilowatts on the lunar surface. These first lunar nuclear reactors would help resolve many technical and operational issues before larger-scale exploitation on Mars. Fuel management, cooling efficiency, long-term reliability, protection against micrometeoroids, continuous electrical power production capacity, interactions with the lunar environment, etc. The collected data would serve to optimally dimension the future power plants that must supply Martian colonies, with the goal of ensuring their long-term autonomy. In parallel, technologies developed on the Moon such as nuclear propulsion could accelerate manned transport to the Red Planet. Optimizing molten salt reactors on the Moon is therefore an essential step before seriously considering establishing a permanent human presence on Mars. Our satellite offers a similar environment while allowing experimentation at lower cost and risk, far from any civilian population. The lessons learned from prototypes first deployed on the lunar surface will directly benefit the sizing of future electronuclear power plants supplying the cities of the Martian future. In this sense, lunar nuclear reactors can be considered a true technological springboard paving the way for the sustainable colonization of the Red Planet. In conclusion, if the conquest of Mars constitutes the holy grail of contemporary space exploration, it cannot be achieved without a crucial intermediate step on our satellite. In situ experimentation of new generations of nuclear reactors on the lunar surface will resolve many technical and logistical issues, while validating reusable technologies for the establishment of the first colonies on Mars. With a view to permanently establishing humanity beyond our Earth's orbit, the Moon would thus fully play its role as the natural testing ground before the final conquest of the Red Planet. Partager.